So what?
Right, sorry.
So the biological facts that we agree on as scientists, we have synthesized what those facts are, even though 50 years from now we're going to look back and say, how could we possibly have thought that?
Right.
So,
smoking was bad for you?
I think, I don't, for this level of course, I don't really have a big problem with knowledge is socially constructed.
So here's why I disagree with you. I almost said agree. Here's why I disagree with you. If you look at the literature on students' understanding of the nature of science, when we bring up things like science knowledge is socially constructed, we end up with a bunch of relativists. And there is something about science where through the extent of our language abilities, we are approximating reality, or at least we're seeking to. That's important for them to understand. And this social construction thing has, at least all Fuad Abd Khalik's work, shows that like we end up with a bunch of relativists, and then they go and teach high school science.
Anything goes. That's your opinion.
And
That's your
really
theory.
Be careful, because I think as a community we have a belief that there is something we're approximating at least with the term atom.
So I want to. This is really helpful. I guess I want to just clarify. These were not things that we said to students that we want you to believe this. These were things that came out of what students were saying in their own language in this particular context related to the papers we read on geology.
Do you think there were votes?
Sorry?
Are there votes on what constitutes scientific knowledge?
Well,
would objects fall differently if the American Physical Society voted to repeal the law of gravity and the French Academy voted to retain it?
But
I think our views are actually more closely aligned than you may think they are. And it is, again, I'm playing with the language, so this is really useful. And I think the thing, maybe to be more precise, the role of the community in determining what's accepted in science was not appreciated by students.
So that's huge.
And I think that was much more appreciated by many students at the end. There were many more references to, well, is that technique widely accepted, rather than is this paper right or wrong? Is this idea right or wrong?
And I think that gets at the distinction that I would make to Alan's comment. No, of course people don't vote on the existence of gravity, but we do vote on the use of the word gravity, as well as the equations that we use to describe gravity, and frankly even the questions that we get to ask around gravity. What are viable research questions around that? All of those things are in fact voted on by, in proxy, through the existence of paper, peer review, funding, and when people are driven off as kooks and misfits in our community or celebrated as heroes. That's my 2 cents. So these are up to 3 cents.
But I like what you're trying to get to with that beginning line. Maybe you just need to work on the language a little bit more.
But clearly also very, very important because people can get stumped up on it. I think talking about models and just as you said, techniques, like what are viable techniques? Those are all things everybody's going to say, well, that's of course.
Do you ever talk about why certain models or certain techniques are accepted? I mean, there is a reason. It's not merely that it's accepted, but there are reasons why it's accepted. It's not a black box.
Right.
And the story of how it got to be accepted goes right to that first line. It's a social activity. Scientists debated and duked it out until...
So I'll work on that.
But it's productive towards
Incentivized
certain
draft.
ends, which is I come back to support
I
Alan's.
don't want to be misleading in what I'm claiming.
Let's
That's
keep going.
important.
But obviously, we should have a whole session on that.
We could. Okay, so this is sort of where we change tack. And instead of approaching this sort of idea with looking at different techniques and trying to give students the kind of insights that we had, experience with the insights we had into different scientific problems, it was more about learning to help, supporting them in being able to read and analyze scientific papers and understanding something about how those papers reflect what's known and what's accepted out there in having to do with these scientific problems, these particular controversies. And so, again, these are, you're going to have to deal with the language because I can't change it on the fly. But I think you have a better sense of what I mean by the language at this point. So we tried to focus our discussion and the kinds of activities we did, again, primarily focusing on where are students at with their ability to read the papers in a way that's meaningful for them to understand what are the claims, and to their ability to evaluate those claims. And so once we sort of understood where they were at, we were able to provide some interactive lectures and other activities that were meant to build up their content knowledge so that we felt they would be better prepared for evaluating those claims. And we feel like along with those then are these sort of ideas about what is in the primary literature, how does that come to be, how does that reflect what's going on in the scientific community, and then that scientific knowledge isn't just a progression, from old stuff that's wrong and new stuff that's right, and that it's not a matter of which paper is right that we're asking you to figure out. It's more of how do you evaluate the kind of claims that are being made in these papers.
Do you look at the structure of papers?
Let me, if you can hold that for a minute, and then ask me again if I don't address it. So this is kind of long, and I want to focus on sort of the first couple things. Without realizing it, what we employed, we figured out later, was actually a contrasting cases approach. Does everyone sort of feel comfortable with that idea?
I don't know.
You don't? Okay. I'll come back to this one. And so this is an idea that has been talked about a lot in the SCI because it seems to have worked in certain circumstances, and Carl really likes it. So this is sort of my articulation of it. And I think the overall goal is for students to get at, and you guys can correct me if I've gotten something a little off, or you disagree at least. The idea is for students to focus on the main concepts and underlying structure to something without telling them what that structure is first. It's supposed to be more effective than that, right? So the idea is you have a couple of examples in which that focus on the same concept, but they're contrasting in some fundamental way. The idea is that students are going to notice the similarities and the differences and pull out important features of the structure of the concept. And then the idea also is that they're more, they're prepared for a lecture or some other sort of instruction on that where the expert pulls out those important things because they've found them for themselves. And the focus is less on getting a correct answer, but more on them, again, picking out those critical features.
You should just mention that it's from Schwartz's.
It's from Schwartz's book?
Work.
Yes, okay. So Dan Schwartz's work.
So Dan, just out of curiosity
Yeah.
then, this is what I was thinking of, but Dan works on very short, tight problems of contrasting cases, where these are papers
Right.
that are so much richer, and it just struck me like, golly, if you did two contrasting cases on geological time, one with your magma tree, and one with, I don't know.
Consider the Grand Canyon example,
a Grand
where
Canyon
some
archer.
people think it has an old origin and some people think it has a new or more recent origin.
Oh, okay.
So
So
that's-
people know immediately. What I wanted to know is
Yeah,
how
yeah.
is it that students know what to cue on contrasting? I guess that was my question.
Well, it's not entirely clear to me what it is that students are actually doing. But what we figured out, and Becky is an expert in many areas that are, content-wise with this, and what she spent a lot of time doing in preparation was mining the literature for papers that were particularly, fit a set of criteria, very clear if they could be, and good papers that set the stage for understanding what the body of knowledge, what's known, what's not known, what's controversial, and sometimes some did a better job of that. So what we found out when we did this, and we didn't do this all the time, but we did it in many cases, is that it really seemed to help students, before we had any sort of other instruction, pick out what was known and not known, what was controversial and not controversial, which was pretty, what is contribution is this paper making that is not known already. And so that was something that was really hard, we found, for students to pick out on their own before. They had no sense of what sort of the standards in the field are and what was known before. And they sort of were taking it as an isolated bit of new knowledge that somebody put out there. Instead, I think it set the context. They were able to pick out the context more effectively. Does that sort of help answer?
Yeah,
So I don't know what functionally it is that they're doing, but they seem to be cueing on those things.
How do they have the context? I can give you examples of a paper which, in terms of its method, in terms of its structure, is beautiful.
Right.
And it was published, and nobody ever referred to it positively again, because by that time the author had lost all credibility in the field. Even though the structure of the paper, graphs and data and everything was beautiful. And so how is a student supposed to judge that?
Well, I guess one thing is students are kind of immune to the authority issue. They don't know any of the names. They don't know any of the history. So that's one thing they seem to be sort of immune to. Does that, I don't know if that answers your
But I think that's a
question.
perfectly reasonable thing to gloss over. You have to, in a course like this, you would have to be able to actually pick apart and analyze the data in a paper before getting into the meta-politics of who's probably right.
It wasn't politics. That's the, you see, we have a fundamental difference. The reason the author of that paper had lost credibility was that he did not respond in any way over a period of some 10 years to legitimate criticism. And his paper it landed with a thud, as one of my colleagues said. That paper might just as well never have been written.
Right, which is a good point for maybe a graduate level version of this course. But I think, how are you going to get them through being able to look at the structure of the paper, try to grok the data in it, and at the same time leapfrog all the way to, well, can I even believe what this person is saying?
This is
in
the first course in learning how to read a paper.
Well,
So I guess the
not
first
a-
thing
not an
I
advanced
just
course.
want to repeat again, they don't have the context of the authorities in the field, and the instructor has done a tremendous job of trying to weed out anything like that and look at what's most relevant. And so I think that was a really critical component, is a very careful choice of papers and problems to look at. And so I just want to, I know we're going to run out of time, so I just want to go through some of the things that we did. And some of these things seem to matter, some of these things didn't seem to matter to students so much, but we think these were all things that were supportive. And the first is that contrasting cases approach. The second is we did do some explicit instruction and modeling of reading and analyzing papers that we think was really important for them to do, and then lots of practice with discussion and writing and feedback. Again, we also were teaching them new content, and so appreciating that they weren't able to immediately use the content they were learning at the level being able to evaluate claims and papers, we tried to scaffold what they were doing throughout the course. So focusing sort of in the first third of the course with a lot of their work focused on the concepts, and then moving more into analyzing. And finally, towards the end, they were asked to do an independent project where they were asked to synthesize a small body of work on a problem and then evaluate the claims that were made in there. And that was sort of more, this was something that was more deliberate. We didn't sort of stumble upon that. That was planned to be that way. We also had a project, this final evaluative or synthetic project at the end. We gave them many opportunities for feedback, and we did it in stages, trying to model what we thought of was important for scientific evaluation. And part of that was using a lot of rubrics for scoring and sharing those rubrics for scoring assignments with the students. I guess the other thing I want to mention is one thing that we came upon was that instead of focusing on a lot of different techniques that would be a huge content load for students, there's one technique that Becky uses for getting radiometric dates on rocks, and it's very powerful, and so